Hi and good morning to friend and doctor. We are from company CNS SD Consult SDM Berhad. Today we are going to present about the group project for subject structure design. First and foremost, we have researched a task to prepare full structure design calculation for bin element by implementing the knowledge linked in the class. Thank you. Okay, move on to the next simply supported bin element. The value of the dead load, life load and other information is obtained by referring to BSN and Ucode standard and also for the material catalog. The dimension size of the stair reinforcement is assumed to be 20 mm for tension zone and 60 mm for the compression zone and 16 mm for link. So the value of the signum obtained from the calculation is 44 mm. Next process to the loading analysis calculation. The value of the shear force and bending moment for the beam is 75.43 kN and 79.20 kN. Respective both value will be used in the calculation to determine the adequacy of the stair reinforcement that has been proposed. As for the detailing, the value of the stair reinforcement required is CH16 and CH20 for the both tension and compression zone, and seat number of the mid stair for the link reinforcement with 250 mm spacing, center per center lah. For the calculation for the continuous beam, first we need to find out the loading distributed from the slab for the all three load case and come up with shear force and bending moment diagram. For the diagram, the highest value of the shear force and bending moment is used to calculate the adequacy of the reinforcement in the continuous beam. The calculation of the continuous beam is calculated by span member for deflection, cracking and spacing value. Find the detailing obtained for the continuous beam element is 2H12 for the tension reinforcement and 1H20 for the compression zone. The spacing link agreement is various according to the value obtained in the calculation. Okay, thank you.
Good morning. My name is Muhammad Kamil bin Abdul Rahim, matrix number CF200175. Now I'm going to continue with the presentation for my part for the simply supported beam which I have chosen, which is 6A B to C. The effective length for this beam is 1800 mm, and after I've calculated the overall depth and the width, I've decided to use the size which is 150 times 400. After designing a stable beam for my simply supported, I conclude that this is the proper detailing for my beam, which is the link that I have used is H6250 and two size of rebar. The first one is 2H12 and the second one is 2H20. Now that's it from my simply supported beam. Let's continue with the continuous beam. The continuous beam that I have decided to design is in the vertical form from 6A to 11, and the first span is from 6A to 9, which is the length is 2500 mm, and the second is from 9 to 11, which is 3600 mm. I have calculated the overall depth and width. I've decided to use the size 200 times 500. Once again, after I've completed my designing for the continuous beam, I've come up with this detailing, and the link that I use for this continuous beam is H6300, while the rebar that I use is the same size but with different amount of rebar, which the size is 16. I think that's all from my part. Thank you. Now I pass to the next member.
Hello, I would like to continue about my part, and my part is firstly is simply supported beam. I choose the beam located with its C1 10 to 11 grid line. Okay, this detailing for the my my beam. This rebar or this link I got from the after I choose the spec from the book and the from the Eurocode, and then I choose the detailing beam C1H20 and 2H20. This part I choose from the AS value is 191.16, and I use the 1H2 20 314 mm2 from the table given. Okay, the link I choose H6 250. Okay, next I will talk about my continuous beam. My continuous beam located at the 11 AF A to F grid line. And now this is my detail for my beam. Okay, the length of beam is 4,800 to 2,400 and 3,500. Okay, I choose 2H20 because my AS value is 368.89, and then I choose use 2H20 6 to 8 millimeters. Okay, that's all for me. About the link is H6 to 300, and okay, that's all for me. Thank you.
I'm Fatin Shamira with metric number CF20033. I will present on how to calculate simply supported beam. The beam that I choose is F811. This is the specification of the beam and the material used. The size that I use for this beam is 150mm times 450mm. The C min that I get is 39mm while C norm is 39, but I make it 40 as my C norm. Next is the calculation of main reinforcement. AS that I get is 408.67mm. So from the table, I use 2H20 as my sectional area, which is 638mm squared. This is the shear reinforcement calculation for this simply supported beam. After calculate, the length that I choose is H6 250. Next is the deflection calculation. The percentage of required tension reinforcement is larger than reference reinforcement ratio. So, use equation 2 to get L over D. At the end, the actual span effective depth that I get is lower than allowable ratio. So, the deflection is okay. Last but not least, the value of bar spacing is lower than maximum allowable bar, which is 4mm. So, it is okay. Here also show the detailing of the beam. Next is the calculation of continuous beam. The beam that I choose is C59. These are the specification and material of the beam. At the beam also, C norm that I get is 40mm, same as simply beam. For the span 6-7 that I get is 39mm, so I choose for size bar 2H10, which is area 157mm squared. Same as span 7-9, I choose 2H10 because AS that I get is 107mm squared, which not more than AS maximum. Next is shear reinforcement. I choose H6 250 as my links for support 9 and 6, and also at support 7. The deflection also okay and pass the allowable ratio. Lastly, bar spacing for this beam is okay, which is below than maximum allowable bar spacing. Here also show the detailing of the beam.